Hello, good evening student. Today we are going to discuss week 1 assignment, and we will also discuss concept which are taught in week 2nd. Okay, so let all join, then we will start. Please wait for couple of minutes. Am I audible? Am I audible to you? Arun, am I audible to you? Arun, are you able to hear me? Yes, student. Am I audible? Hello, am I audible to you? Yes, student. Am I audible? Hello. Priya, Sharin, Dhana, am I audible?
Yes, sir.
Am I audible to you?
Yes,
Yeah,
sir.
yes, sir.
Okay, okay, okay. And just a minute. Are you able to see my screen?
Yes, sir.
Okay, okay, okay. Then
Yes,
we'll
sir.
start. Okay, thank you. Okay, so now we are going to start. Okay, we will discuss week number 1 assignment. Okay, because prior to your due date, we cannot explain ongoing week assignment. Okay, otherwise all will copy the answers. So we will discuss assignment of previous week, and it will be follow for future also. Okay, so myself Harish Kumar Trivedi, and I am going to start now. The first question of assignment number 1 was, the first fully synthetic polymer bakelite was synthesized from. Okay, so we need to find out which were monomer used to synthesize bakelite. Okay, so bakelite is a scientist name. So accidentally he produced bakelite by reaction of phenol and formaldehyde. Okay, so phenol and formaldehyde is right answer for this question. Okay, we will discuss about the formation and the synthesis of bakelite in next slide. So this is the correct answer, phenol and formaldehyde. So I think you know about the structure of phenol. This is known as phenol, one OH group on benzene ring. It is known as phenol, and it is a formaldehyde. Okay, formaldehyde means it is one CO group. Okay, so it will be CH2O, this one. So here you can see that 1 mole of phenol and 3 mole of formaldehyde react, and it first it will produce tri-substituted phenol. Okay, tri-substituted, you can see one, second, and third. Okay, so it is substituted, and then when it will be heated, water will be removed. Okay, and it will produce a double bond CH2 here, and it is double bond carbonyl CO group like. Okay, then if it is further react and further react with formaldehyde and all, so cross linking will be generated, and finally a cross linked bakelite will be formed. Okay, because it the property of bakelite, which is very hard and insulating to electricity and all. It has various application for domestic and industrial purpose. So it is very famous that days, and it is also used nowadays also. So it is a revolution for the in material science, and that's why it is very popular. So it was first produced by Bakelite in 1907. Okay, and it is produced through the reaction of phenol and formaldehyde. I think this question is clear. Any doubt you can ask. If you have any doubt regarding this assignment or the ongoing lectures, you can ask me. Okay, you can stop me and you can ask me. Okay, otherwise I will not able to know how where you are getting problem. Okay, so you need to initiate and you need to ask. Okay, now we are moving to question number 2. Let me see somebody in waiting room. So yes, admit. Okay. So we have done first question. Now we are moving to second question. I hope my screen is visible. If not, then please inform me. Okay, so question number second, numerical. You are able to see this polymer, okay, because this is n time this monomer is repeated to form this polymer. So what question is asking? The approximate value of the degree of polymerization, dp, we need to know for the above polymerization with the number of average molecular weight, uh, 1 lakh. Okay, so how you will find out? Okay, so it will be dp will be 2n here. Why it is 2n? Because you can see that in a repeating unit, two monomers are repeating. Okay, in repeating unit, two monomers are there. So degree of polymerization will be 2n. Okay, so you can find out simply dp can be find out by uh, total molecular weight. Okay, divided by molecular weight of one unit. So one monomer or one repeating unit, we can say one repeating unit. Okay, so you need to find out that how much molecular weight. Okay, sorry. So first of all, we will find out the carbon, how many carbons are there. Sorry. So 2, 2, 4, 6, 6 plus 6, 12, 12 and 1, 2, 3. So 12 and 4. So 12, 16. Okay, am I right? 6 plus 6, 12. 12 plus 3 and 4. So 12 plus 4, 16. Okay, so 16 into 12. Then oxygen. So how many oxygens are there? 3 oxygens. Okay, so it will be 16. Then hydrogen. So hydrogen will be 2 plus 2, 4. 4 plus 3 plus 3, 6. So 10. 10 plus 4. So 14 will be hydrogen. Okay, so according to that, we can find out the molecular weight. Let me use just a minute. So 16 into 12 is equal to 192. Then 16 into 3, it is 48, and it is 14. Okay, so when you find out, it will be 8 plus 2, 10, 4, then 1, so 10 and 5, then 1 will go 252. Okay, so 254 is molecular weight of this repeating unit, so it will be 254. Then because there are two monomer, two monomer are there in this repeating unit, so we need to multiply this by 2. Okay, now if you will find out, divide by 254 into 2, so it will be around 787.402 approximate. Okay, so this is the answer. So correct answer will be this. Okay, clear? I think this question is clear. Any doubt you can ask. If you why we multiply 2, if you have this question, then you need to find out that there are two molecular units, two monomers are participating in one repeating unit, so we need to multiply by 2 as taught in week 1 lectures. Okay, now yeah, so see, it is all also explained here. Okay, so same formula which I used, I just explained the formula, then I used this formula, so it is more clear. Okay, now question number 3, identify type of polymerization reaction given below. Okay, so you need to find out type of polymerization. Okay, so we have already discussed in lecture, sir has already taught that there are two types of reaction. First is addition reaction. Okay, addition means one initiator is there. Okay, just a minute. Yes, suppose this uh, hollow circle is initiator, then it will initiate monomer. Okay, and the chain will be continue like that. Okay, so this is called as a addition polymerization. And second is step condensation, yeah, step polymerization or condensation polymerization, or these are the common names. So in step polymerization or condensation polymerization, what will happen, the molecule will be condensed, means some byproduct will be formed, small byproduct like H2O, HCl, HNO3, NaCl, like that. Okay, so and in addition reaction, the backbone will be carbon. Okay, so the backbone of the polymer will be made of carbon. However, in the condensation reaction, the backbone will be made of heteroatom like oxygen, nitrogen, sulfur, etc. You can see here. So this is the addition reaction. Okay, so when one monomer will be react like that, CH2, CH, CCl, and CH2. Okay, so this is the monomer. When it will react with another monomer, let me write here CH2. We are writing head head to tail arrangement. Okay, because you can see that this is the tail of this molecule and this is the head of this molecule. Okay, so when it will react, suppose they are making one bond. Okay, so this bond will be break. Okay, so let me, okay, so this double bond and this double bond will be break. Oh, just a minute, let me write it again. CH2, CH, C, then CH2. Okay, so this new bond is formed between these two molecule. Okay, so here this bond will be break and there this will be break, so it is active side here, and similarly it will make double bond here and it is the active side. Okay, so by adding these two monomer, we are getting dimer. Okay, we are getting dimer, and we are also getting two active side on the both end of this dimer. Okay, so it will again reaction will be continue and it will be propagate. So this polymerization will be propagate further, and it will make a big chain of polymer. Okay, so it is called propagation of this reaction, and this is called also tail to head or head to tail addition, and this is called addition. Simply it is called addition. So first reaction is addition reaction. Second, we can see this is the dicarboxylic acid monomer. Okay, two carboxylic acid is there, and similarly two hydroxyl group is there, alcohol group is there. Okay, so two alcohol and two carbonyl carboxylic acid group are there. So when they will react, it is not depend head to head or tail to tail, because both end are same. Okay, we can assign this as a head, or this tail, or this head or this tail. Both are same. Okay, so it is not no need to worry here. Okay, in either direction they will react, and they will form what they form. Just a minute. They will remove one hydrogen from here and one OH from here. Okay, so they will remove water. Okay, water molecule will be removed and it will be linked. Okay, so it will be condensation reaction. Okay, so by explanation of this reaction, it is clear. Okay, so first one is addition and second one is condensation reaction. Okay, so these are the two type of reaction which occur in synthesis of polymer. Is it clear? Okay, let me check if somebody in waiting room. I request you all to please join on time. Okay, so that I need not to. Okay, now question 4. It is very interesting question. A polymer having very steep slope in a plot of stress versus strain and long elongation at break can be described. Okay, so what is stress and strain? Okay, so first of all, stress sigma is known as force upon area. Okay, so how much force is applying on particular area is known as a stress, where strain epsilon is delta x upon x. Delta x is means change in its dimension, its length, its area, whatever. So change in the dimension. Okay, so when you applying force on any object, it will change its area or its length. Okay, suppose this is the one piece of metal. Okay, if you are pulling it from the both side, it will be elongated like that. Okay, so how much area or how much length is changed, we measure this as a strain, and how much force you are applying per area is known as a stress. Okay, so when in simple understanding we can say when I will apply stress, there will be some elongation. Okay, so if I don't know anything, then I can plot a simple graph that when I will apply force, strain will be there. Okay, and finally it will be break. Okay, so when I will apply stress on any object, initially it will be deform. Okay, it will be its length will be increased, its area will be decreased like that, and finally it will be break. Okay, so our question is asking that a polymer having very steep slope in a plot of stress versus strain and low elongation. Okay, elongation is low means strain is low. Okay, elongation is described as a strain. Okay, so strain is low. So what the question is asking that it is asking that you are applying the stress, but it is low elongation. So the graph will be just a minute. Graph will be increase like that. Okay, means you are increasing stress, but elongation is very low like that. Okay, and finally it will be break here. So we can say this type of graph is made for plastic, no, tough fiber, yes. Okay, so if fiber are tough, they will not deform. If you increase the stress, finally they will breakdown. Okay, an elastomer, no, elastomer will be behave differently. Okay, because in if elastomer is there, then if you apply little force, little stress, you can say, it will be elongate more like that. Okay, so it is the stress strain curve for elastomer. Say brittle plastic is also similar to tough fiber, but it will be elongate like that, little bit like. Okay, so this so tough fiber is the right answer of this question. Okay, so the same graph it is already taught by sir. Okay, so here you can find out for tough fiber plastic, brittle plastic, sorry, tough fiber and brittle plastic, plastic with yield, okay, and elastomer. So here this is the very good property. Okay, in plastic it is formed. So when you elongate in this area, the necking will be formed. Okay, so if it is okay, suppose this is the specimen where which you are going to analyze. Okay, by applying stress in both direction. Okay, so what will be happen, it necking will be there. So I'm not able to draw a very good picture, but for your understanding only. Okay, so this specimen is changed from here to here. So here this area is necking. Okay, this area is elongating more. Okay, so this area will be replicate the necking of the polymer. Okay, clear? Any doubt you can ask me meanwhile. Okay, it is not that I will speak and you will hear. You can also interact, so it will be very nice. Okay, question number 5. Which of the following statement are incorrect in step growth polymerization? Okay, so step growth polymerization you all know. Okay, so what will happen, dimer will be formed, trimer will be formed, tetramer, hexamer, heptamer. Okay, this mers will be formed. Finally after some time there will be big mers like that. When they will react, they will form again big chain. Okay, so initially small molecule will be formed. Okay, and after that, after a long time, uh, big chain will be react in between and they will form further bigger chain. Okay, so degree of polarization will be increased very much at the end of the reaction. Okay, so this is the basic step in the degree of step growth polymerization. So there are some statements we will check one by one. High molecular weight at low conversion, no. This is the incorrect, because high molecular weight will be at high conversion. I told na, at the end of the reaction, this big chain will be react and make further bigger chain. Okay, so this will be happen at the end of the reaction. Okay, so high molecular weight will be produced at higher conversion, not lower conversion. So this statement is incorrect. Okay, then we are moving further. Product is the product is the reaction mixture, no. Yeah, it is correct. Product is a reaction mixture. In here, all the reaction mixture is your product. So this is the correct statement. Then need shorter reaction time? No, it is taking a long time. Okay, because when you will find significant length of polymer, okay, significant length of these chains, then their reaction rate will be very slow. Okay, so it will require a very high time. Okay, so this statement is wrong. Then finally, no initiator is needed. We know that initiator is needed in addition reaction. Okay, addition polymerization. Okay, so it is not required here. Okay, so it is correct. Okay, so what will the incorrect statement? First and third. First and third is first and third are incorrect statement. Clear? I'm explaining each question nicely so that your concept will be boosted up. Okay, so here also I added what are the change between chain growth and step growth. Okay, so in chain growth it required initiator. Okay, but in step growth it do not require. Second change is growth occur by successive addition. Okay, we know that in addition reaction one by one molecule is adding, but growth occur through matrix by reaction between monomer, oligomer. Okay, oligomer or means smaller chain like that. Okay, after some time they will react. Okay, so it is like that, but here one each time one molecule will be added and it will be continue like that. Product is a isolated polymer. After uh, after synthesis of required polymer you need to separate it out, but in step growth polymer the whole reaction mixture is your product. Okay, then no byproduct formation. Okay, byproduct formation will be not there. Okay, but in it will generally form byproduct. How? Why it is forming byproduct? Because this reaction is done by condensation reaction. Okay, so whenever condensation reaction is there, small byproduct like H2O, HCl, NaCl like that, this small molecule will be formed. Okay, then high molecular weight, even lower conversion, because this reaction is fast. So after some time only you will able to find out high molecular weight. But here high molecular weight at very high conversion. Okay, at the end of, because at the end of synthesis only bigger chain will be react. Okay, so you will be able to find out high molecular weight. Generally by addition reaction, we already know chain growth will be done by addition reaction, but here it will be done by condensation reaction. It will be carbon carbon backbone. Okay, C like that, but here O N, this type of bond will be formed, and it will form some condensation molecule. Okay, so heteroatom will be there in the backbone. Shorter reaction time, but it will take longer reaction time. Okay, generally low to moderate reaction temperature, but it require high reaction temperature, because after some time it will produce a viscous polymer, and to handle this viscous polymer you need stirring, you need high temperature and required pressure and all these things. Okay, so I think up to 5 question it is clear. Okay, now we are moving to question number 6. A polymer has the following structure. Okay, the common and IUPAC name of the polymer. Okay, so for common name you need to find out that which monomer is repeating. Okay, simply. So this is if you see, if it is not making this bond and it is not making this bond, then it will be simply like that. Okay, so this group is known as a vinyl. Okay, it is group this group is known as a vinyl, so it is vinyl alcohol. Okay, so common name will be polyvinyl alcohol. Simple. Okay, polyvinyl alcohol. Then IUPAC name. Okay, so IUPAC name you need to write down the IUPAC name of this repeat monomer. Okay, so it is two carbon is there. Okay, so if one carbon is there, then methanol. So there are two carbons, so it is known as a ethanol. So polyethanol, simply polyethanol. So this is the IUPAC name and this is the common name. So B is the right answer of this question. Am I clear? So it is explained here. Okay, the common name of monomer which is the polymer is synthesis is vinyl alcohol. Hence the name of polymer is polyvinyl alcohol. However, IUPAC name you need to write down the IUPAC name of monomer which is ethanol. So the name will be polyethanol. Okay. Now question number 7. Question number 7 is for a hypothetical monodisperse polymer. Okay, it is already written here. Hypothetical. It is not possible to produce monodisperse polymer. Monodisperse polymer. So what is the monodisperse polymer? Means if any polymer has equal degree of polymerization. Each and every chain of polymer has same degree of polymerization, which is not possible. Means you are saying that all polymer, if you have any polymer which has many chain, and each chain has 100 molecule. Each chain is 100 molecule. No, it is not possible. Some will be have around 80, some 90, some 100, some 110, some 120, like that. Okay, so this type of distribution will be there, but you are this condition is hypothetical. Okay, so the number average and weight average molecule weight are related according to. Okay, so if it is hypothetical monodisperse, so it mw, okay, number average and weight average will be similar because it is monodisperse, no change are there. Okay, so mw will equal to mn. Okay, so here it is written. So monodisperse polymer are uniform polymer in which all molecule have the same degree of polymerization or relative molecular mass. Okay, so their relative molecular mass or degree of polymerization are same. The polymer has monodispersivity index. Okay, so what is the dispersivity index? Is ratio of weight molecular divided by molecular weight, number molecular weight. Okay, so it will be 1. Okay, so this is the seventh question. Okay, okay, so here uh, weight average molecular weight and number average molecular weight ratio will be 1. Okay, it is for hypothetical monodispersive polymer. Now question number 8 again. Okay, so here some questions we are explaining, but I suggest that you need to find out what are the IUPAC name of various functional group, various monomer. Okay, so you need to find out IUPAC name, how to write IUPAC name of organic compound. Okay, then you will be able to answer other question also, because we have some constraint and we can explain only some monomer here. Okay, name of some monomer and like that, but you should be master in this nomenclature. So you have to analyze or you have to study further about the IUPAC name of organic compound. Okay, now so what this question is asking, the general name of the polymer having the following group in the main chain. Okay, so poly, we know that poly will be suffix. Okay, but you need to name of this monomer only. Okay, so this monomer is known as uh, arylenes. Okay, so polyarylenes, and it is sulfones, S SO2 sulfones. So it is polysulfone. Okay, so polyarylenes and polysulfones will be name of IUPAC name of this polymer. So option C is correct. Okay, so now we will discuss this comprehensive type question. Okay, so we need to find out number average molecular weight, average molecular weight. Okay, data are given here. A polymer sample has the following composition. Okay, so these are the moles. Okay, number of moles are given here. Okay, and molecular weight is given here. Okay, so suppose I am just giving name first, second, third, and fourth. If I have one mixture of polymer, okay, which has first type of chain, which molecular weight is zero point 0.5 and its molecular weight is 8,000. Similarly, I have second type of polymer chain, which molar 0.15, it has 30,000. Similarly, third, and similarly fourth type of monomer, which has these moles and this molecular weight. Okay, now we will find out. Okay, so these are the formula. This formula are already explained in class, so I am not repeating here. Okay, so first of all, we will find out the number average molecular weight, which is mole fraction of particular polymer and mass of particular mole. Okay, so here these are the moles of particular. Ni means it can be, I can be 1, 2, 3, 4, like that. I am just giving name 1, 2, 3, 4. Okay, so N first type of polymer has zero point 0.5 mole and it has molecular weight uh, 8,000. So first of all, I will find out the Xi. Okay, so Xi will be Na upon sigma Ni. So sigma Ni, you need to add all this. Okay, you need to sum this all thing. Okay, so it will be 25, 15, 30, 40, 30, 40, 40, 60, 0.65. Okay, summation will be 0.65. So here first of all ni, so let me check what will be this. So it will be ni upon sigma ni. Okay, so it will be zero point 0.5 divided by 0.65. Oh, we are doing some mistake. Zero point 0.5 plus 0.15 plus 0.25 plus 0.20 plus 0.25 plus 0.20. So it will be not 65, it will be 1.1. Okay, 0.5, 0.15. Okay, zero point 0.1. Then you need to find ni. So zero point 0.5 divided by 1.1. Yes, now it's okay. Okay, so here what you are doing, zero point 0.5 divided by 1.1. Similarly, here you are doing 0.15 divided by 1.1. Here 0.25 divided by 1.1, and here 0.20 divided by 1. Okay, so by doing this, you are getting this value. Okay, so okay, first thing is clear. Then xi into mi. Now mi is given here. This is the mi. So xi now 0.45 into 8,000. Okay, so you will get 36,000. Okay, 0.45 multiply by 8,000, you will get this value. Similarly, you can find out another value, and finally if you add it, you will get sigma value. Okay, so we find out this thing. Then ni into mi. So ni is are the mole of various polymer chain. Okay, then mi is molecular weight. So again, zero point 0.5 into ni into mi, you need to multiply. So it will be zero point 0.5 into 8,000. Yes, so you are getting fund. So here you need to multiply zero point 0.5 into 8,000. You will get this value. Similarly, you can multiply here 0.15 into 30,000. Okay, so similarly you can find out this value. Okay, finally you need to multiply ni into mi square. So first of all, you need to multiply ni square. So here uh, how you will find out this value, 8,000, you just do square of this thing, then just multiply by zero point 0.5. Okay, so 8,000 into 8,000, okay, into zero point 0.5. So you will get this value. Okay, similarly other also you can find out, and then you will find out sigma value of all this thing. Okay, now you need to put the value in formula, and you will get the value of number average molecular weight mn. So it is nothing but sigma xi mi. So we have already find out sigma xi mi, this one. Okay, so it will be mn. Second is uh, weight average molecular weight. So it will be ni square, sigma ni square. So this value divided by ni. Okay, divided by this value. So you need to find out mw 272 divided by, so 30 will be cancelled with 3. Okay, then 272 divided by 15. Okay, so you will get 18.133 into 10 power 3. Or if you multiply this 10 power 3 here, you will get 133. Okay, so this is answer here. Okay, now finally we need to find out pdi. What is pdi? Polymer dispersive index. Okay, so it will be mw divided by mn. Okay, so you just put value like that. Okay, and you will get 1.32 is PDI. Okay, so this question is also clear. We have we have sorted out all these three answer: MN, MW, and PDI. Okay, then question 12, very basic question. I think this is the most simplest question of this assignment. Okay, so here we need to find out the type of polymer. Okay, so here it is simplest copolymer. Okay, alternative copolymer we can say. Okay, alternative copolymer. Then somebody in waiting room. Let me check. Okay, so if my screen is not visible, please tell me. So if it is alternative polymer, and this is also copolymer, but you can say that there are different type of blocks are there, A, B, C. Okay, because their color are different, so we can assume that these are the different blocks. Okay, different blocks of copolymer. So you can say it is a tri-block polymer. Okay, tri-blocks copolymer. Okay, then here, so you can see that one backbone is there, and another small branches are there, which is made of different monomer. Okay, so we can say it is a draft copolymer. Okay, draft copolymer, and finally this is the simple polymer only. Okay, nothing. So a homopolymer we can say. Okay, so these are the name: alternate copolymer, tri-block copolymer, draft, yeah, graft, we can say. Okay, graft polymer, and finally homopolymer. This is the homopolymer because all monomers are same. That's why it is called homopolymer. Okay, question 12 is clear. Now question 13. Okay, it is asking about this is the distribution of molecular weight. Okay, it is a weight fraction, and it is a molecular weight. Okay, so weight fraction means you can say that higher molecular weight fraction is low. Okay, similarly lower molecular weight fraction is also low, but at some limit the weight fraction is highest. Okay, so these are the thing, and we find out molecular weight by different method: number average, weight average, viscosity average, and like that. And you need to find out. Okay, so it is already told in class that. Okay, so what will be highest molecular weight? So you can find out here. Okay, so okay, first will be Mn, because Mv, Mw, and Mz. Mz will be highest. So here it will be Mz. Here will be Mw, Mv, and Mn. Okay, so it will be answer of this. So C will be answer of this question. Okay. Then finally, question number 15. Here also we have a numerical problem. Okay, and we need to find out the value of weight average of polymer XW for the sample. Okay, so here what data are given. Okay, so various fractions are given. Okay, and their weight fractions are given, and their molecular weight also given. Okay, so what is this? Finally we need to find out that weight fraction is given. Okay, so from the weight fraction, how we will find out number average and molecular number average and weight average molecular weight. So these are the formula. You need to find out wi upon mi. So wi first of all, so you need to divide wi, weight fraction, divided by molecular weight. Okay, so 0.12. Here you need to divide 0.12 by 6000. Okay, you will find out this value. Then here you need to multiply this thing: 0.12 into 6000. Okay, just check it. So WI is 0.12 divided by 6000. I think that there are some mistake, okay, in this question, because when we are dividing Wi by Mi, we are not getting this value. Okay, so I think some values are different. So we need to confirm it first. 0.12 divided by 6000. No, we are not getting this value. Similarly, zero point 0.2 divided by 8000. Yes, we are getting this value. Okay, when we are dividing zero point 0.2 by 8000, we are getting this value. Similarly, when we are multiply zero point 0.2 into 8000, we are getting this value also. Okay, so let me correct it. Okay, so 0.12 into 6000. So this value will be 720 and 0.12 divided by 6000. So this value will be 2 into 10 power minus 5. Okay, so this value is I have already checked 16, and let me check third value. Zero point 0.4 divided by 7000, so 5.7. Yes, it is right, and it is also right. Then last zero point 0.3 weight fraction point, so it is also right. Yes, okay, so only we need to change these values. Okay, then you, what you need to do, you need to do only summation. Okay, and whatever your summation is there, then you need to number average molecular weight will be 1 upon this value. Okay, you just add it, what value will become. Okay, we can add it also here. 2.0, then 2.5, 5.7, 3.0. Okay, so it will be uh, then 1, 2 plus 2, 5, 5 plus 10, 13. So it will be 13.2. Okay, 2, 5, okay, so it will be 13.2. So value will be, Mn will be 1 upon 13.2 into 10 power minus 5. Okay, so when 1 will be divided by 13.2, so you will get value around 0.0757. Okay, multiply by 10 power 5, because it will be, now it will be positive, the power will be positive. Okay, or you can say it will be 7570 around. Okay, because yes, this will the value. Okay, so this will be Mn, and similarly uh, this value sigma Mi, weight average molecular weight, so you can add this value, or 720 plus 1600, 2800 plus 3000. Okay, so it value will be 8120. Okay, So MW will be 8120 and this value will be 8,000. Now you can find out XW also. Okay. So you need to just divide by 86. I think it is not given here. Mole, degree of polymerization 86 is weight of one ball. Okay, I think it is given in questions. Question is not here. Okay, whatever. If you divide it by what value we get 8,120. If you divide it by 86, you will get XW. Okay. So these are the question assignment first. These are the questions of assignment first. We have already discussed. Okay. Up to here, any doubt? Or we will discuss some concepts of last week, week number one. Sorry, week number two. Now we will discuss concepts of week number two. Okay. So let me start. I think my screen is visible. Again, introduction to polymer science. Are you able to see this screen? Student, are you hear me or not? You are not reacting in the class. Are you able to hear me?
Yes, sir.
Ha. So my another slide is visible to you.
Yes, sir.
My another slide is visible to you. I am sharing different slide. Another slide. Is it visible, na? Okay.
Yes, sir.
Okay. Okay. So I am giving you 2 minute break. After 2 minute break, we will start concepts of week second. Okay. sorry. Yes, are you ready? We are going to start now. Okay, the second module of this class. So now we'll discuss about the concepts of week second. Okay, first of all, we will discuss about the step growth polymerization. It is also known as a step polymerization for short form. Okay, so these are the reactions where you are able to see how step growth polymerizations are formed. Okay, here uh, these are example of polyamide. Okay, so amide, this CO and NH bond is forming here. Okay, so simply it is condensation reaction only. You are also able to find out some byproduct. Okay, so you are here, we are able to find out H2O, but here because X is there, halogen is there, when it will be remain to diamine, it will form HX. Okay, it might be HCl, HBr like that. Okay, so here you are getting different byproduct. Okay, so otherwise polymer is almost same. Okay, because it will be removed and chain will be grow. So polymer will same, but byproduct are change. It is depend on your monomer. Okay, similarly this monomer contain both carboxylic group and NH2 amine group. Okay, so it is the structure of basic structure of amino acid. Okay, amino acid is, what is the amino acid? Amino acids are building block of protein. Okay, amino acids are building block of protein, and they are making polymer like structure by the condensation reaction only, where H2O will be removed and they will form this amide bond. Okay, so these are the things about the step growth polymerization. Okay, so polyamide is explained here. Similarly, other step growth polymerization, which are used for engineering and high performance polymer. Okay, so here you can see that this di alcohol monomer, when reacted with this carbonyl. Okay, so it will also produce polycarbonate. Okay, plus byproduct HCl, and this is the potassium salt of this monomer. Okay, when this potassium salt of this monomer will be react, it removed K from here, Cl from here, KCl, and by you can say head to tail arrangement, it will form poly uh, polyether sulfone. Okay, polyether sulfone. So it is ether group and a sulfone group, polyether sulfone. Okay, similarly, you can make some conducting polymers. Okay, what is the meaning of conducting polymer? Means polymer which are able to conduct electricity. Okay, how polymer? We generally know that polymer are insulator of electricity. Okay, because they do not have free electrons, so they are not non-conducting of electricity. But here, some polymer are conducting of electricity, and they are attracting their applications in batteries, supercapacitor, and many others. Okay, so how they are, see this structure, these all structure are uh, conducting polymer. Okay, so by the conjugation of this double bond, okay, by the conjugation of this double bond, the electron are able to conduct electricity. Okay, in this, so this polymer are able to conduct electricity, so that's why they are using for electrical applications also. So polyurethane examples are given. Okay. So isocyanate groups contain monomer, various monomer. Okay. These all are contain isocyanate group. When it will be react with another polymer, monomer, sorry, another monomer, they will polymerize and produce polyurethane. Okay. So polyurethane. So you can see here CONH RNHCO. Okay, so these are the repeating unit of polyurethane and polyurea polyaddition. Okay. Now we will discuss about the functionality of monomer. Functionality of monomer means if just a minute, what happened? what is the functionality of monomer? Just suppose you have, suppose it is one person. Arre, okay, so I think, huh. Okay, so suppose there is one person. Okay, he has two hands. Okay, so he or she can hold to another person by these two hands. Okay, similarly, monomer also have hands which can act for polymerization. Okay, so here in this monomer, it has two hands. From here and from here, it can polymerize. Okay, so from these two ends, it can polymerize. So its functionality R2. Okay, similarly, this glycol has three hands. Okay, so from three side it can make polymerization, so its functionality is three. Similarly, diol, it is also has two functionality. Here it can make bond from four side, so its functionality is four. Okay, now uh, if any monomer, or we can say if any organic compound which has only one functionality, okay, so it can react with any chain, but because it has only one functional group, okay, so it will react like that. It will, okay, because it do not have any monomer here. It sorry, it do not have any functional group in this side. It has only one functional group this side, and it has already reacted. So now it cannot react further. So it is stopping chain. So that's why it is called chain stoppers. Okay. So examples are given here. Only one functional group, so it will be react from this side. Okay, stop. Now no reaction will be happen. Similarly, it will react from this side. Now no reaction will be happen. Okay, so it is these molecules are called chain stopper. There are no monofunctional monomers. Okay, so there are no monofunctional monomers. If any organic compound contain only one functional group, it is called stopper. It is not, it will not called as a monomers. Okay, if F is equal to 2, okay, I have already told you, if suppose this is the molecule and it has F is equal to 2, so it can react from this side and it can react also from this side. Okay, so it can make a chain, linear chain. Okay, if F is equal to 2, it will form linear chain macromolecule. Okay, and if F is equal to 3, okay, or 3 or more, means more than 2, so 3 or 4, whatever, so it can make chain from each functionality. Okay, so it will make branch macromolecule or a network structure. Okay, so I think functionality of monomer is clear. So in linear step polymerization, you can see there are two type of monomer. Okay, one is AB. AB means one monomer contain two different type of functional group like this OH and COH. Okay, another type we can use separate monomers. It contain AA both side, and another monomer which contain BB functional group both side. Okay, so according to our application, we can select either one strategy for the synthesis of your required polymer. Okay, so they will make so here if it is OH and COH, then it can make head to tail arrangement. Okay, but if is AA and BB, then it doesn't matter how it is head and tail or head. Okay, because it can if this monomer will react from the either side, it are same. Okay, so it will not think to bother. Okay, now we are going to discuss very important thing. Okay, linear step polymerization. Okay, degree of polymerization and conversion. We will able to make some understanding between relationship between degree of polymerization, conversion. Okay, and how polymerization is there, how step polymerization is there. So understand, this is a very simple example, but it is the you can say key of the all the numerical problem, and all the findings are which we are going to deal further. Okay, so in this example, here you can see that this is the monomer which contain two functional group. Okay, it is shown by different color. So there are six monomer contain two functional groups. So total, so n is equal to 6. Total molecules are 6, and each molecule contain two monomers, two functional groups. So there will be total 12 functional group. Initially, at time is equal to 0, nothing is reacted. So react, reactions functional reacted functional groups are 0. So 0 divided by 12, 0 means conversion is 0, no reaction is happened, and degree of polymerization is 1, because the weight of you can say dp. How you will find dp? No upon n. Okay, so no is 6 and it is also 6, so it is 1. Okay, now after some time you can we are just assuming time. Okay, it is not correct, but we are just assuming time after 5 minutes. Okay, it is not correct time, but I am just to for understanding, I am just assuming this time. After t is equal to 5, 5 minutes, after 5 minutes, two molecule reacted and make one molecule. Okay, others are same. So now if you count the uh, number of monomers, oh sorry, number of you can say molecules, so there are 5 molecules only, because one is dimer and 4 are monomer. Okay, so how many functional group reacted? 2. And how many was there? How many were there? How many functional groups were there? So 12 were there. So 2 upon 12, it is 0.17. Degree of polymerization is 0.17. Now you will find out degree of polymerization. So it will be how you will find out? NO. So NO are 2 into 1. Okay, because two molecule react in this. So 2, then 1 into 4, and n is reacted. Okay, what is the meaning of n? N is after reaction how many molecules are remain, or how many molecules are formed. Total molecules are formed, so it are 5. Okay, so n means how many molecules are formed after 5 minutes. So there are 5 molecules. Okay, so 6 here, it will be 6 divided by 5, so you will get 1.2. Okay, so this is, I explained this thing only. Then after you can say time is equal to 10 minutes, time is equal to 20 minutes. Okay, whatever time, 30 minutes. Okay, so after various time we measured the polymer conversion rate. Okay, here for functional group reacted, 6 reacted, 8 reacted, 10 reacted, whatever. Okay, and similarly uh, as monomer reacted together, the molecule number are decreased. What is the meaning of m? N. N means molecule formed after the reaction. Okay, or how many molecules are there after the reaction? How many molecules are there after the reaction? So after 5 minutes there are 5, after 10 minutes there are 4, and like that. Okay, so dp you will find out this formula n upon n, and you will get different value. Okay, so it is okay. Now polymerization is there, and degree of polymerization is there. Okay, now we uh, just increase this data and find out. Okay, we understand this thing what is happening. Now we are uh, just making our data larger. So here we are taking n is equal to 100. Initially no reaction, so conversion is 0. Okay, and dp is 1. Then 50 molecules are there, so 50 are reacted. So 50 are reacted means 100 functional group are reacted, so conversion is zero point 0.5. Then 25, 13, 7, and 1, whatever. Okay, then now see the conversion. Here 0.50, here 0.75, zero point 0.8, 0.93, 0.910. And finally, just see the degree of polymerization: 2, 4, 7.7, 14.4, and 100. So why I am reading this data? What is the thing behind that? I want to explain. So here if you see, when 100 to 50, okay, so how many molecules are reacted? 50. Okay, so half, you can say half number of molecules are reacted here, but okay, because conversion is also zero point 0.5, but degree of polymerization is only 2. Okay, half molecules are reacted, but degree of polymerization is just double 2. After that, here to here only 25 molecules are reacted, but degree of polymerization increase 4. Okay, so here also it is double, but here in the first step 50 molecules need to react to increase its degree of polymerization to make it double. Okay, 1 to 2, but here only 25 molecules need to double degree of polymerization, 2 to 4. Now here to here, see, 13 to 25, it is already around 12 molecules reacted, which double the polymerization, 4 to 7.7, around 8, we can say around 8. Okay, so here also degree of polymerization is double, but only 12 molecules is reacted. Here from here to here only 6 molecules are reacted. Okay, but here degree of polymerization is also double. Okay, but here from here to here again, how many? 6 molecules are reacted, but degree of polymerization is how many times? So just see, just let me calculate it. So it is a 100 divided by 14.3, so 6.99, around 7 time. Okay, so in last step here degree of polymerization increase by uh, yes, yeah, so degree of polymerization increase by 7 time here. Okay, by reacting only 6 molecule, degree of polymerization reacting 7. Now can you think why it is happen? So initially 50 molecules are reacted, but degree of polymerization just double, but here only 6 molecules are reacted and degree of polymerization increased by 7 time. Why it is happening so? Because initially only monomers are there in your reaction mixer. When this monomer are react, they made dimer like that. Okay, after some time they made trimer. No, trimer, or you can say tetramer, because 2 plus 2 it will remain it will make tetramer, and 2 plus 1 it will make trimer. So in third step trimer and tetramer is formed. In fourth step you can say this tetramer and trimer react, so 7 mer or 8 mer will be formed. Okay, and after like suppose after n time you will find 1000 mer react with 1000 mer. Okay, so when 1000 mer react with 1000 mer, it will made 2000 mer. Okay, by only one molecule. Okay, two molecules are changing, two molecules are reacting, and they are just getting a polymer which has 2000 mer. Okay, so degree of polymerization increase in the latter case, because after when reaction conversion rate is very high, around 0.99 or 0.99 or around to complete, they are very big molecules. Okay, at the completion of reaction they are very big
Sir, your
molecules.
screen is.
Sorry, can you repeat?
Sir, now only your screen is visible, sir. That's why I'm asking, sir.
So you need to tell me na initially, otherwise how I'm asking same question again and again. So please let me know if you are not able to see. Okay, okay, now you are able to see na.
Okay, sir.
Yes, now you are able
Oh,
to
yes,
see.
sir.
Okay, okay. So what I am telling, that when conversion is about around 0.99, or you can say when reaction is about to complete, in your reaction mixer, there is very big molecule. Okay, big chains, big oligomers are there in reaction. So when these chains will be react in between, okay, the degree of polymerization will be increased very high. Okay, initially one molecule monomers will be react, so degree of polymerization will be not increase for very significant amount, but at the end of product where a big oligomer will be react, or you can say n mers, which are 1000 or lakh nmers will be react, so your degree of polymerization will be increased drastically. Okay, so that is the why I need to explain this graph. I think it is clear, because it is the basic of your understanding which we are going to discuss further. Clear? Any doubt? Up to here, any doubt? Student, any doubt up to here? Are you able to understand or not? Please let me know. Okay. So see here, whatever I told in last slide, it is graphically explained here. Okay, it is the degree of polymerization and it is the conversion length. Initially, the polymerization is not changing significantly. Okay, but when reaction is about to complete, when conversion rate is around 0.99 or around 1, the polymerization increase further because here small molecules are reacting like that. Here little big, you can say trimer or tetramer. Okay, this type of molecule are reacting here. Here little bit longer molecule like that. Okay, this type of molecule are reacting, but here at the end of chain, I'm just making this chain to make you understand. It is not a way to measure. Okay, so okay, so now condition first, condition second, condition third, and condition four. Are you able to see my screen? Student, are you able to see my screen?
Yes, sir.
Ha. So see here. So initially when these monomers are reacting, the dp is not changing significantly here. Okay, initially when conversion is very low. But when conversion is very high, these bigger chains will be react among each other. Okay, and the dp will be increased drastically. Okay. So this graph is clear to you how why this dp is changing at the end of the end of the reaction when conversion is very high. Okay, conversion is 0.99 or point here means here reaction is completed. Okay, here reaction is completed. Okay, and here it is the starting of reaction. Starting of reaction. Clear? So starting of reaction, a small molecule will be react so that dp will be not change significantly. But after high conversion, more than zero point 0.9 or around zero point 0.99 or around completion of reaction, very big molecules or very big oligomers are there which finally react to complete the reaction. So your dp will be changed significantly at the end of reaction. Okay. So let me check if somebody in waiting room. Nobody in waiting room. Okay. So I think. Okay. So is it clear? So student, tell me, is it clear? Otherwise, if I will move further, then it will be very complicated. So this concept is clear or not? Why degree of polymerization is increased at the end of reaction or at higher conversion rate? Clear? Say yes or no at least. Am I audible or not? If I'm not audible, audible, then it is waste of time. Am I audible? No. Yes, Dana, Prithvi, Sherin, are you able to hear me? Are you there, student, or you are just logging and Sherin, Dana? Okay, so I think am I audible now? It is due to connection loss. I was just left the meeting. Am I audible now?
Yes, sir.
Yes, sir.
Okay. So this concept is clear now. Why degree of polymerization increase at the end of reaction? Is it clear? Okay. It is also explained here. See, initially monomer react. So this condition will be applicable for this here, around here. Okay. Then trimer, dimer, trimer, tetramer. Okay, so you can see up to here. I'm just making a rough understanding. It is not like that. Okay, and this pentamer, hexamer like that. It will be react like that. Okay, and big molecules, oligomer like 100 mers, 1000 mer. Okay, big molecule which will be react at the end of reaction. Okay, so that's why degree of polymerization increase drastically at the end of reaction. Okay. So this is the linear step polymerization. It is explained here. Okay. So by this way we can find out the molecular weight Mn. Okay. It is a degree of polymerization. Then M average, a molecular weight average of repeating unit, and finally the end group. Okay. So this equation is we can find out the xn. Okay. So finally, first of all, we how we find out conversion. So n reacted divided by no. Okay. So n reacted means initial molecule concentration of initial, then concentration of molecule formed at time t. Okay, so it will be NO minus N. So N reacted divided by NO. So you can simplify this 1 minus N upon NO, or further we can simplify N upon NO is equal to 1 minus P. So Xn is equal to NO upon N. Degree of polymerization we already derived this formula N upon N. So NO upon N will be equal to 1 minus, because see here it is N upon NO. So you are just inverting it. Okay, N upon N. So 1 minus P will be invert. It will be 1 upon minus, sorry, 1 upon 1 minus P. Okay. So by this way you can find out the degree of polymerization. This value you will put here. Okay. This value we can find out the mass of average molecule, average repeating unit, and then finally end of unit, and we can find out the mass of polymer. Okay, so we will do some numerical problem also. Okay, so this xn finally which we derived in previous slide, degree of polymerization is equal to 1 upon 1 minus p. It is known as Carruthers law. Okay, Carruthers equation, and this is the final equation from where you can find out the molecular weight. Okay, so see here in this problem, find the Mn value. Mn means molecular weight, average molecular weight. So number average molecular weight of polymer formed by the reaction of 1 by 1 mole of. Okay, so it is 1 by 1 mixture of acetic acid or ethyl glycol, and conversion is 99. Okay, so conversion rate is already given. So by conversion we can find out the degree of polymerization 1 upon 1 minus p. So we just put the value. Okay, so we will get 100. Okay, by this way we can find out degree of polymerization. Then you just put this value in to find out molecular weight of this polymer. Okay, so it is 100 and it is 86. 86 is what? 86 is molecular weight of average molecular weight. Okay, so average molecular weight will be 170 divided by 2, because there are two monomer are reacting. Okay, so repeating unit contain two monomers, so it average molecular weight will be molecular weight of repeating unit divided by 2, 170 divided by 2, so it will be 86. So here 86 is kept, and uh, last it is 18. So 18 is nothing but it is stopping the chain. So it is a weight of molecular weight of stopper. Okay, so 18. So finally you will get 86 over 18. So it is 18 is looking little bit odd. Okay, in front of 8600. So we can round off this thing like that, 86,000. Okay, so by this way you can find out the molecular weight of polymer. Okay, so in the previous question, in previous slide, so we discussed where two monomers A and B concentration was same, molar concentration was same. But here, if we are putting one monomer in excess, okay, here this diamine, if we are putting this diamine in excess, then the end uh, the end of unit will be the excess monomer, okay, because all monomers of this dicarboxylic acid is already consumed, there is nothing, okay, so last the chain will be stopped by excess monomer. Similarly here diamine is in excess, here dicarboxylic acid is excess, so end group will be same, okay, it is a very common understanding. So if one monomer is excess, you need to use this formula. Here R is nothing but a ratio of Na and Nb. Okay, so this ratio should be always less than 1. Okay, so how it will be less than 1? When you will put bigger value here. Okay, bigger value means the monomer which concentration is higher. So always put the monomer concentration, higher monomer concentration at the denominator. Okay, so you will find Ra R value less than 1. Okay, so like that, because here we have Nb higher. Suppose we are assuming that Nb higher, so we are putting Nb here. Okay, and we will find out value of 1 less than 1. Okay, so then you will able to find out degree of polymerization. Okay, it is little change because we are taking one monomer in excess. So similar here, you can also add stopper. Okay, so if you are putting, see, if simple monomer, so if A is equal to B, okay, concentration of A is equal to concentration of B, so you need to find out Na is equal to Na upon NaB. Okay, by simply, okay, it is B. Okay, but if one monomer is in excess, A is equal to not is equal to B, okay, because one monomer concentration is excess, then what you how you will find out the value? The formula is this one, 1 plus R divided by 1 plus minus 2 Rp. The formula is same, okay, formula is same, but here R value you need to find out. Here how you it should be less than 1 na? But if it is monomer, then you need to find out Na should be Nb plus 2Nb. Okay, so like that you can find out the R value for the different condition. Okay, because time is limiting me, I cannot explain very in detail. If you have any question, you can mail me or you can write on forum. Okay, so here this is the Carothers expression we have already explained. Okay, xn is equal to 1 upon xn is equal to 1 is upon 1 minus p. Okay, if it is equimolar. Okay, if it is not equimolar, then you need to find out the bigger value here. Okay, see, if NB is higher, then you need to find then you need to put NB as a denominator, and if Na is higher, then if you need to put Na is denominator. Okay, same. So what are Na and Nb? You already know. Na is number of functional group of A, Nb is number of functional group B. Okay, or Nb dash is a number of stopper. Okay, so like that you can find out. The formula will remain same to find out Xn for the if A and B concentration is not same and if stopper is there. Okay. So see, Xn formula is same, only you need to find out R value by this equation if stopper is present. Okay, number of B molecule present. Okay, so linear step polymerization controlled by chain stopper. Okay, so you need to find out chain stopper concentration. Then yeah, this graph is also explained. Okay, so first of all, I just want to tell you that you can make your concept by graph reading. Okay, if you are very good in graph reading, then you can understand concept very clearly. Okay, so here you can see this is degree of polymerization and this is the conversion ratio. Okay, 100 upon 101, 100 so what is going on here, that 101, 102, 102. Okay, so initially na is equal to nab. Okay, so ratio will be na upon nb will be same 1. Okay, if na concentration is equal to nab concentration, then ratio will be 1. Now you are increasing nb. Okay, you are increasing nb one by one, 101, 101, 101. So when you are increasing nb, means you are disturbing this balance. Okay, initially it was na is equal to nb. Now because you are increasing the value of nb, so now it is not na is equal to nb. So when you are disturbing this equation, okay, your polymerization, degree of polymerization is also decreasing. See, the graph is decreasing like that, na? Okay, so graph is decreasing like that. Why this graph is decreasing? Because you are disturbing the na is equal to nb by increasing the value of nb. Okay, second concept by second concept you can understand by this graph, that the conversion, that at higher conversion, the degree of polymerization is higher. Obviously it will be higher, because at higher concentration bigger chain will be react. Okay, so conversion will be higher. But yeah, higher conversion. But here also, if you are disturbing this ratio, then its polymerization rate is decreasing. Okay, so these two or three concepts you can understand by this graph. Okay, now by solving this numerical problem, you will able to understand what the effect of disbalancing this concentration of Na and Nb monomer, or if you are going to isomer, then how it will affect the degree of polymerization. Okay, so see what this example is explaining, that polyamide from the reaction of acetic acid and hexamethyl diamine. Okay, polyamide from the reaction of, okay, you are going to make polyamide by the reaction of acetic acid and hexamethyl diamine. Okay, so first condition is molar ratio is 1 by 1. Okay, so 1 by 1 molar ratio means Na is equal to Nb. Okay, concentration is same, so ratio will be 1. Okay, and action will be highest. We have already explained by this graph. Okay, because ratio is 1, so action will be highest. See, by putting this conversion rate here, you are able to find out the degree of polymerization 200. Now we are moving to second condition, where you are putting only 1% excess. Okay, acetic acid. Okay, so acetic acid is Na. Okay, so now you are keeping Na higher. So how you will find out R you need to find out Nb upon Na. Why I am not writing Na upon Nb? Because here Na concentration is higher. So to find out, to keep this ratio less than 1, equal or less than 1, I need to find out Na here. Then only ratio will be less than 1. Na? So I put Na like that. Okay, and then I find out degree of polymerization by this formula, and if you solve it, you will able to find out the degree of polymerization 100 only. Okay, just half. Okay, what you did, you just increase the concentration by 1%. See, it is very less, 1% concentration. By it can be mismatch also by it can be if you are measuring concentration by some analytical tool or some analytical apparatus, or by manual error. Okay, 1% error is very common. Okay, but see, by doing this 1% excess, the degree of polymerization just decrease by half. Okay, so it is very good concept to keep you in mind, that what is the importance of keeping Na and Nb concentration same. Okay, further, if you are putting all conditions similar to 1. Okay, if you are putting all conditions similar to 1, but you are adding only 1% excess of acetic acid. Okay, 1% benzoic acid, sorry. Okay, addition of benzoic acid. So what this benzoic acid will be do, this benzoic acid will be act as a stopper. Okay, and how much you are adding? Only 1%. Here you are adding, but this type of concentration can be there as a impurity also, because no chemical is pure, na? So 1% impurity can be there. Okay, it is very common. So if 1% impurity is there, then it can reduce your degree of polymerization 67. Okay, so from 200 it is now 63. Okay, so I think now you can understand that what is the meaning of maintain the concentration of Na and Nb, and what is the meaning of taking pure solvent, sorry, taking pure monomers. Okay, taking pure monomers, and taking pure monomers, and there should be no stopper. Okay, it sometime it can be also there that you are taking pure monomers. Okay, you are taking pure monomers, then also sometime your degree of polymerization will be decreased drastically. Okay, so why it is happening? So it is due to side reaction. Okay, sometime side reactions are there. Okay, this side reaction will produce some stoppers. Okay, which will prohibit your reaction, and it will result in decrease in your degree of polymerization. Is it clear? This concept is clear or not? You can ask me, you can interact me, student. I am explaining very in very detail. Is it clear now? Am I audible? I think. Am I audible? Okay. Now this is the statistical theory where you can find out that molecular weight distribution in linear polymerization. Okay, linear polymerization is going on. Then how you can find out that xmers are present, monomer, dimer, trimer. Okay, so you need to find out the concentration of this xmers is present in how many amount. Okay, so by this way, this formula, you can find out the concentration of xmers. Okay, or you can also find out the weight fraction of this xmer. Okay, by using this formula. We do not have to derive this formula. We just, let me see if somebody in waiting room. Nobody in waiting room. Okay, yeah, somebody in waiting. Okay, so by this way we can find out the monomer concentration of monomer, dimer, trimer, xmer, whatever you are going to find out after reaction. You can find out by this most probable distribution of Fleury. Okay, according to that you can find out this thing. So see how we will. I will give you one example, and by this way you will find out. Okay, when equimolar step growth polymerization is 99% complete. Okay, your reaction is about to complete. 99% is complete. What fraction of reaction mixture is still monomer? Okay, your reaction is still about to complete, and you are going to find out monomer. Okay, which is the starting of your reaction. Okay, your reaction is completed. So you are saying that 99% is complete. So how much my monomer will be there? So it is already by seeing, by reading this statement also, I can say 1% will be there. Okay, similar 1%, na? Only 1% monomer will be there because 99% conversion is already there. So on the mole basis and on the weight basis we will calculate. We will calculate by this formula. Then also we will find out this 1% also. See, it is nx upon n. So nx is the monomer, number of monomer, or n is the molecule which produced. Okay, so nx upon n will be the what say, it will be fraction of mole fraction of this xmer. Okay, so it is nx upon n. This is the 1 minus p x. So what monomer you are going to find out? Monomer. So you will put 1 here. Okay, so 1 minus 1 0. So each value, p value will be 1. So 1 minus p. Okay, and conversion is already given here 0.99. So if you put a value, so nx will be 0.001. Okay, it is a mole fraction. If you find out percentage, so you need to multiply by 100. Okay, so you will find 1%. Okay, so 1% of monomer will be there. Now you need to find out that how much weight fraction of monomer will be there. Now you are going to find out how much weight percent of this monomer is present. Then again you need to find out you need to put value in this formula. X is equal to 1 because monomer we are going to find out. Conversion is 9, whatever. You need to find out this value. So it is 0.01%. Okay. So it will be 0.01 weight percent only there. Weight only 0.01 weight percent of monomer is present in your. Why it is very low? Because now you have make very bigger chains. Now your chains degree of polymerization is very high. So in respect of that, their weight fraction is very low. Okay. So that's why the value of this is very low. I think it is clear. Okay. You can also read these two graph. Okay, to understand better. It is nx. What is nx? nx is nx is what? Fraction of xmer. Okay. So you can see here when conversion is very high, the xmer, the xmer concentration is means you can say here is it is 0, 50, 100. Okay, it is the you can say molecular weight. Okay, so lower molecular weight fraction is very low here. Okay, but if conversion rate is low, then the lower molecular weight fraction, not weight fraction, sorry, mole fraction will be high. Okay, similarly here weight fraction is explained. So when conversion rate is low, the weight fraction of lower molecular weight molecule is high, it is increasing. It is when conversion is increasing, it is higher molecular weight is shifting in right hand side direction, and at very higher conversion rate you can see that the bigger molecular bigger molecular weight fraction is higher compared to lower molecules. Okay, so it can be understood like that. Okay, so why it is happening that this slide is repeating again? Why it is happening that? Because initially small molecules are reacting and small monomers, small mers are creating this reaction, but at the higher conversion, bigger molecules are reacting. Okay, that's why these are making bigger molecule. So that lower weight fraction molecules, sorry, lower weight fraction, you can say oligomer will be there compared to higher molecule. Okay, just let me see. Okay, so up to here I think it is clear. Okay, then see, to understand the kinetic of this polymerization, we have to what say, we have to make some assumption. Okay, like suppose this is the monomer which has A and B. Okay, two functional group A and B are the functional group. So their reactivity, we assume that reactivity is same. Okay, reactivity of both functional group of the bifunctional monomers are same. Okay, it is a little bit if you are organic chemist, then it will be a little bit hard to understand how it is same, but in polymer it is assumed that it is same, because it suppose it is COH, one side it is COH, one side it is OH, but in polymer chemistry it is assuming that both are same reactive. The reactive of one functional group, a bifunctional reacting, is the same irrespective of whether the other functional group has reacted. Okay, sometime the neighboring functional group also affect the reactivity of functional group due to plus I effect, conjugation, and many phenomena is there in organic chemistry. They affect the reactivity of their neighboring group. But here also we assuming that there is no effect on the neighboring group. Okay, either it is reacted or not reacted. Okay, and the third is the reactivity of the functional group is independent of size of molecule. Okay, it is also contradict with organic chemistry, because yeah, steric effect, if you know about the steric effect, then if any functional group which has some steric hindrance, then its reactivity will be affected. But here we are not considering this factor also. Okay, we are assuming that if functional group is there, then its reactivity will be same. Okay. So here the kinetics is explained here. So these are the two oligomer, you can say. When they will react in the presence of catalyst, they are making a big chain. Okay, catalyst is again separated out. Okay, so here we are assuming that it is a irreversible reaction. Irreversible reaction means you are going to remove some byproduct from this reaction, so this reaction will not able to move backward. Okay, that's why it is called irreversible polymerization. Okay, AB type monomer or equimolar, we are taking equimolar concentration all. Okay, we are not changing this thing, we are taking equimolar. Okay, equal concentration of this A and B. Then obviously the rate of reaction will be described by the changing the concentration of reactant. Okay, so if suppose the concentration of A is A in bracket. Okay, so it is changing with time, so we can say d upon dt. Okay, so it will be defined rate, but because it is reactant and with time it will be decrease, that's why we need to put minus sign. Okay, so it is written here, see, reaction rate of this polymerization will be equal to minus dB upon dt, means concentration of B reactant decrease with time. Okay, d upon dt. Then similarly d upon dt decrease. Okay, it is equal to. Okay, so you can take any one concentration. Okay, either A or either B. So it will be equal to what? K. Okay, reaction constant. Okay, then concentration of A and concentration of B and catalyst, because the catalyst we know that catalyst concentration will not change. Okay, so it K dash and K catalyst will be constant, so we put another constant here, K AB. Okay, so this is the rate law of polymerization. So similarly, if you can so our concentration is same, we already told you here that because it is equimolar. Okay, so we can say A has concentration C and B has also concentration C. Okay, so at the place of here you can put K C C. Okay, 2 times C. Here A concentration is also C and B is also C, so you can put 2 times C. Okay, so Kc square. Okay, so here initially it is a means decreasing of concentration of delta C upon delta T is equal to Kc square, because concentration of A and B both are same. Okay, then it is you need to integrate this equation. Okay, so you will able to find Kt 1 upon Cl. Okay, then you can put then you can find out C from this equation. Okay, if you further solve it, and finally you will able to find out this degree of polymerization equation. Okay, xn is equal to 1 CO. If you solve it, you will able to find out easily. Okay, it is not a big problem, because C, how you will write C? C is a CO. CO means initial concentration minus CO and conversion. Okay, so conversion at that time, if you multiply with the initial concentration, you will able to find C. Okay, so you can put this C value here. Okay, if you put this value here, okay, you will able to find out this equation. Okay, so here it is given that xn degree of polymerization increase with time. We already know that obviously reaction will be increased with time. Okay, so it will be increase in the presence of external catalyst. Okay, so see here we are going to explain one another very good concept. Okay, I think it will be last concept because time is not permitting me. Only 6 minutes are remain. So the kinetic of step polymerization. Okay, and we are taking external catalyst added. Okay, so so that the time required to go 0.982, it is dot double dot, it is you can say 0.98 to 0.99. Okay, it is the conversion. So see, already 0.98% reaction is completed, and from 0.98 to 0.99, how much reaction is increasing? 0.01. Okay, so you can see that 0.98 means almost reaction is completed. In our common language, we can say it is 0.98 out of 1, 0.98 is completed. So what we will see? It is almost completed. But see how much time will be take from 0.98 to 0.99. Okay, so this is the gist of this concept. Okay, so I will explain you. Just a minute. Okay, so where so that the time required to go from 0.98 to 0.99 is very close to the time to reach 0.98 to the start of reaction. Okay, see how it is there. If you will find out the time required, okay, time required to 0.98 conversion. So what the formula, this is the formula. If you will put the value of conversion, it is 0.98, then KCO use it is just keep constant. Okay, K is constant and CO we are assuming it is constant. Okay, because it is in our hand initial concentration. Then it is 1 minus 0.98, whatever you will solve, you will get 49. Okay, 49 KCO. Then point 0.9 0.98 to 0.99. Okay, so point if you are going to find out time required for 0.99, so you will you will able to find point sorry 99 divided by KCO. Okay, so suppose we are taking simple mathematics. So 49 means 49 minutes required to complete reaction. How much? 0.98, or you can say simply 98%. Okay, to complete reaction 98% you required 49 minutes, and 99 minutes required to complete reaction 99%. See how much reaction is increasing, only 1%, but how much time is required here? 50 minutes. Okay, so see from start, this is the starting point of reaction. So starting reaction from here to here means from 0 to 98 it took only 49 minutes, but 98 to 99 it took 50 minutes. Okay, means more than the time required for 98%. Okay, so finally in one sentence I want to say that reaction polymerization will take a longer time for completion at the end. Okay, initially reaction rate will be higher, but at the end of conversation the reaction rate will be very slow. Okay, that's why it required very high time. Okay, so I think it is clear, this concept is clear, I think. Any doubt in this concept? Any doubt? Okay, if it is clear I am going to stop here only. Okay, I able to discuss only some concepts. There are many concepts actually. I able to clear only half of them. Okay, so many slides are remain, but whatever, if you have any doubt you can write me, or you can okay, you can write in the forum, so I will able to answer. Okay, any doubt? Otherwise I need to stop the class. Okay, any comments, any doubt, you can write in chat box also. No, if you are not able to speak, then you can write in chat box any doubt, any comments. Are you able to understand or not? Are you able to understand these concepts or not? Whatever. Okay, so Dana, Kalais, Sarmila, Dr. Manju, M, and one Arvind, I think Arvind Kumar. Are you there? Are you able to hear me? Anyone?
Yes, sir.
Yeah, so are you able to understand?
Yes, sir. Understood.
Okay. Okay, then we will meet in next class. Till then, bye bye.